Alright, so we need to get started with quantifiers and proofs. Quantifiers are everywhere. They're on Wikipedia, they're in textbooks, they're in papers. You got to know them. Then the two quantifiers are for all and there exists. So for all means literally for all. Like it's there's some predicate, there's some proposition P, and oops, wait, I did that wrong. If it's for all x in A, P of x, that means if A is a finite set, we could go one at a time and show that P of x is true. Here, I'll just make it simpler and write is true. P of x is true. It's a proposition, is true of the first item in the set, is true of the second item in the set, is true of the third item in the set. So just to really beat a dead horse is if I say for all x in, let's use the set inclusion symbol. For all x in 0, 1, 2, comma, x is less than 3. And what that means is you do a list, like a for loop, if you're a programmer. 0 is less than 3, 1 is less than 3, 2 is less than 3. Right? And if that's true, 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 then you have a for all quantified statement. Now, the fun part is if we'll be saying for all x in... Here, I got ahead of myself. We'll be saying for all x in the natural numbers. Okay? We'll be saying for all x in the real numbers. Right? We're talking about for every vector in f to the n, for some n, dot 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 dot. These are infinite, right? Infinite. So you can't just enumerate, you can't just list out. All right, so we're going to be doing for all over infinite sets. And in order to do that, you're going to have to understand proof. I'm not teaching proof in this video. I'm just going to go over one of the principles that tells you what kind of proof and when. So the other quantifier is exists. There exists an x in 0, 1, 2 such that odd of x. Right? So what you do is the fact that 2 is not odd is fine because this is exist. And exist means at least... Ooh, that was bad. What happened? I bumped a button. Let me get it back on track here. At least 1. Okay? Exists means at least 1. At least 1 x in 0, 1, 2 is odd. Right? So you can see here, what's the proof of this? Well, the proof is that 1 is in 0, 1, 2, and 1 is odd. Right? It's as simple as that. So here's the pattern. Here's what I'm telling you, and here's what you have to internalize, and here's what you have to take down to your notes, because it's going to come up on the exams really quickly. Is if you're proving a positive, you're proving something true, and you have a for all, that's going to be in this tricky zone that requires proof. But if you're proving a negative and you have a for all. So if you're disproving something, and you have a for all, you provide a witness. Okay? And what I'm doing is I'm making a table. Is if you have a for all and you're disproving something, you provide a witness, and that suffices for a proof. Okay? Now, if you have it there exists and you're proving a positive, you're proving it's called an existence proof. And with that, you can do with a witness. As in, you pick something from the set, just like we picked the 1 out of it when we were asked to prove that an item in 0, 1, 2, at least one item in 0, 1, 2 is odd. We picked out 1, right? An example of this case where it's a for all and a disproof is if I had a proposition for all x in the natural numbers, odd of x. And the only thing I need to do to disprove this is to say 2 is in that. And not odd 2. That's the not symbol right there. It means not. This is a proof. It's a disproof, okay? This is a disproof. And it's a witness. It's a disproof by providing a witness because it's a disproof with a for all. Got it? So these are the easy cases. These are the easy cases. These I can teach you in a 5-minute video. Exists positive, that's a witness. For all negative, that's a witness, right? But for all positive, you need a proof. And there exists negative, you need a proof. And these are harder. So I'll circle this in... No, I was going to circle this in green. Green, because it's easy. And here I'm going to circle this in red because you have to do some work. Because it can be difficult. It can be easy. There are times when it's easy, but there are other times where this is where it's difficult. Okay? So this is the table you want to internalize. Let's get rid of the... this is the table you want to internalize, okay? This table. This table is the money. It's going to help you on your exams.